Today we are looking at Kelusa's law of combining volume. It said when gases react, they do so in volume. So number one, you should notice they are gases and they do so in volume. So we have an example here. This is an hydrogen that's packed with 30 centimeter cube of oxygen at 150 degrees Celsius according to the following equation. So they say state which gas is in excess and the volume by which the gas is in excess. Calculate the volume of residual gas. Now, if you want to know the gas that is in excess, you have to calculate using their mole ratio. But this time around, the mole ratio is in form of volume. So you can see we have 40 centimeter cube of hydrogen. Then you make it 8 centimeter cube of oxygen. So from here we have 2, that is the 2 underline, 2 centimeter cube of hydrogen to 1 centimeter cube, underline 1 centimeter cube of oxygen. So we end up having 20 centimeter cube of oxygen. So in that case, the only one that is in excess is oxygen, because we started with 30 centimeter cube of oxygen and we end up with 20. That is a reasonable what? A reasonable combustion. It means it's used up 20 out of 30. But when you start with 30 and you end up with 40, that is not a reasonable combustion. So it is not accepted. You can see me tick it, it is accepted. But the second one, I try to calculate for hydrogen. I have 60 centimeter cube of hydrogen. Please take note, hydrogen must be under hydrogen and oxygen must be under oxygen. So if you use 30 centimeter cube of oxygen, at the end of the day, you will use 60 centimeter cube of hydrogen. And you started with 40, you end up with 60, which is not what? Reasonable, is not possible. So that is why it is not accepted. So the first one is accepted, which is oxygen. The gas that is in excess is oxygen. It is oxygen gas. And calculate by which is in excess. So we want to know. That will be 30. We started with 30. 30 minus the 20 that is used up. We have 10. Then we have to calculate the volume of residual gas. The volume of residual gas is volume of excess or unused plus volume of product. You calculate the product. The product is H2O. So we have 40 centimeter cube. You use that 40 because the one that is used up is 40. So that you use 40 centimeter cube of hydrogen or you use 20 centimeter cube of oxygen. Either of the two. So when you use 20 centimeter cube of oxygen, you see arrive at 40. Or you use 40 centimeter cube of hydrogen. 40 centimeter cube of hydrogen will give 40 centimeter cube of water. Because it is 2, it will give 40 centimeter cube of water. And that is the combustion. That is the product. So you add up 40 plus 10 will give us 50. So we have 50 centimeter cube of residual gas. You have an exercise under. So 2200 centimeter cube of hydrogen was packed with 80 of oxygen with the gas measured at 15 degrees Celsius. What was the volume of residual gas? You can see volume of residual gas. You are asked to calculate the volume of residual gas. If you know the volume of residual gas is volume of excess plus volume of product. So for you to get that, you need to calculate the volume of excess. And looking at this, look at the way it is 201 200 versus S, then 21, you will end up with 100, which is not what? Which is not possible because you started with 80 of oxygen and you end up with 100 of oxygen. It's not possible. But when you use 80 of oxygen and you end up using what? 160 of hydrogen, that one is what? Is possible. Is what is possible. So hydrogen is a gas. So you can get your excess from there and calculate the volume of the product. If your product is 2, you will calculate 2 products. But this time around, the volume is 1. The product is 1. So you calculate the volume of the product one time. That is the solution. Try it. God bless.